You might have noticed that sometimes if you touch the handle of a door, specifically the metallic ones, you might get an electric shock. Or sometimes what happens if you travel on a long distance on a motorway, for example, and you touch the handle of the car, you might get an electric shock. Or very commonly in winters, you might have seen or you might have experienced some electric shock when you touch a blanket, for example. Or one person touches another person in winter, specifically if they are wearing jumpers, there might be buildup of charge and they might get electric shock. So in this video today, I'm going to explain some basic science behind it, and I will be using some sort of lab operators that I have got today, and I'm going to explain that why it happens. So if you are interested, please watch this video. I'm Harrison here, and welcome to my Facebook page and YouTube channel. As I said earlier, that I'll be discussing about static electricity. So before I start this video, I'm going to start off with some sort of demonstrations. So I'll be starting off this with balloon over here. So I've got a balloon, and if I try to stick with let's say the whiteboard, you can see it simply falls down. Now if I pick it up and I rub it with my hair a little bit, and I will try to stick it, you can see that it is now able to stick on the whiteboard. Now what has happened here, what is the science behind it? So I'm going to explain in this video today, but before that I'll be demonstrating few more examples as well. Now if you see what I've got a comb and I have got some pieces of papers, and if I try to pick them up, you can see they are not again picking up. So what I'm going to do, I will be going to rub this piece of plastic, which is basically a comb, with let's say my hair, or let's say any other piece of cloth. So for example, I can use my tie and I can just rub it off and see whether we can pick some papers or not. So I have rubbed it for a few seconds and I'm just going to pick some papers. So you can see that I'm able to pick some pieces of paper. So what is happening here, why this piece of comb, or why this comb is now able to pick some papers? So before I start explaining this, I will be using another demonstration, which is what we call a Venn diagram. Now if you see, this is what we call a Venn diagram, and what we have got a dome over here, and basically there is a moving belt. So if I turn this on, you should be able to see some sort of spark between these two spheres. So let's see what happens when I just turn it on. So if I just turn it on, you can see there is some sort of spark that is coming out. You can visibly see as well. And this is the principle behind, if you have seen thunderstorms, when the clouds are basically rubbing through the air, you might have seen lightning in everyday life. So the fundamental principle is exactly the same, which I have not explained yet, but I am just giving you different examples that what actually can happen. So if you see over here, what I'm going to do, I'm just going to first of all discharge it. So I'm just going to place this metal sphere with another one. So the electrons which are there on the surface, they will be redistributed. And now what I'm going to do, I'm just going to put some aluminum foils. All of them are right now, they are metallic in nature. I have not turned it on. I will just place it on top of the Venn diagram, and let's see what is going to happen. So I'm just going to turn it on and then see the magic. So you can see all of them suddenly fly off. Now if a person has got long hairs, and if they are standing on an insulating object, let's say plastic, and if they hold this dome, you might have seen in the videos in the YouTube that their hair basically fly off. So let's imagine that this is some like these are plastic hairs. Basically I'm just going to place on top of it, and I'm just going to see what is going to happen. So right now I've just inserted over here, and I will just turn it on, and let's see what is going to happen. So if you see, you might have noticed that all of them have suddenly gone up, and they are basically spreading around in different dimensions. So what is happening here? So in this video today, as I said, I will be discussing the main principle behind the static electricity, and I'm going to explain that what is happening here and why we feel these electric charges everywhere in nature. I can also demonstrate using one more example. So if you see over here, I've got these are some polythenes, balls basically, and they are attached to a string, and I'm just going to attach it on this Venn diagram sphere as well. and DOM we call it, and when I turn it on, you will be able to see that they will rise up and they will start repelling each other. So you can see suddenly all of them, they are basically going in each different directions. So now I'm going to explain the fundamental principle that what is happening and why it's happening. So fundamentally, everything is made up of atoms, and if you know the basic structure of atoms, we have got protons and neutrons in the nucleus, and we have got electrons, which in the standard or basic model we say that electrons revolves around a nucleus, but in actual model of an atom, electrons are not orbiting in fixed shell, but there's a probability that comes in quantum physics, but I'm not going to go into details. But what happens when we rub two materials together, whatever those two materials are, sometimes it happens it can happen with conductors or insulators, but mainly if you have got two insulating materials, let's say plastic, when we rub them together, what is going to happen? Electrons are transferred from one material to another. Remember, protons are not transferred because protons are basically they are in the nucleus and they cannot be moved out easily. Obviously, you need to break a nucleus to remove proton, but electrons can move from one material to another very easily. So this is what is happening actually. So basically, when you rub two material together, you have seen in the Venn diagram as well, there is a belt. So when it moves around, the electrons are basically transferred from one material to another, and there is a charge build up. Now, and if there is another object which is not charged, which is maybe neutral, then when we try to bring another charged object with an object which is neutral, there will be a charge redistribution, and the electrons where they are in excess will try to travel through the air to the another material, and this is why we can see some sort of you might have seen in thunderstorms or clouds, lightning. Basically, you might have seen there a little bit of lightning between two spheres as well. So basically, when electrons travel through the air, they basically ionize the air, and this is how we can see some sort of lightning. And this is how two materials can stick together. So basically, if one material has got extra electrons, when we attach it to a material which is neutral, in neutral material there will be a charge distribution. The electron will get repelled, and there will be what we call a temporary positive charge or induced positive charge. So negative and positive charges, they attract each other, and you have seen that the balloon actually got stuck with the wall or the whiteboard. And same thing happens when I use the comb. So initially the comb and the pieces of paper were also neutral. There were no net charge, but when I rubbed the comb with a piece of cloth, what happened was electrons were transferred from one material to another. So it might be the comb getting more electrons, or it might be possible that the comb is actually losing electrons. So we never know. It actually depends on the electron affinity of the material, but generally what happens, one material will get more electron and other material will lose electron. Now when I bring that comb towards a neutral papers, so there will be a charge misalignment. So let's imagine that the comb has got a negative charge, so all the electrons of the paper will be repelled from the negative charges of the comb, and they will go away. And obviously on one side there will be a positive charge on the pieces of paper. We call it induced charge because electrons have slightly moved away. So that side of the paper and the electrons of the comb, they will attract each other, and both of these things will stick together. And the same principle happens in every sort of static charge that we see in everyday life. I gave you an example of the comb, or like the metal knob, for example, that I gave earlier in the example, that when you try to touch a knob, it might be possible that your body is charged because of some reason, or maybe you're wearing some wool clothing, and because of that your body might have built some charge, and when you try to touch it, the electrons from your body will be transferred from your hand to the metallic knob, and in that process you feel electric shock. So I hope in this video I have tried to explain in simple details that what is actually happening when we experience these sort of electric shocks. If you have any questions, if you have anything to ask, please do write in the comment section. I'll be happily answering those questions. Thank you so much for watching my videos. I'm Hassan, signing off.